Good morning. So I'm going to work on the Chapter 5 test review video. So for Chapter 5 test, so remember to make your note card. Okay. Okay, so what we need to do, so Adriana drives an average rate of 55 miles per hour for 165 miles. How long will it take? So that means that we're solving for time. And so we're going to use distance is equal to rate divided by time. I'm solving for time, so I'm going to go ahead and divide the distance divided by the rate. Okay, so we're going to divide those two. So time is going to be equal to distance divided by the rate. The distance is 65 miles, 165, and the rate is 55 miles per hour. Okay, so we go ahead and divide those. Okay, and I get 3, so it's 3 hours. Okay, so it says Melissa's car cost $28,000. It depreciates at a rate of 5% per year. How much will the car be worth after 8 years? Solve for y. So we're solving for y. So we're going to use this, our exponential depreciation rate formula. Okay, so remember we need to change the rate to a decimal. So 5%. We're going to drop the percent sign and go to the left to the left. So it's going to be y is equal to 28,000 times 1 minus 0.05, and then our x is 8 years. This is our rate. Okay, so our rate is 8 years. So 28,000 okay, and I get 18,575 and 77 cents. Okay, for the next one, so it says the car depreciates at 6.5% per year. Julio brought a 4-year-old Honda for $18,600. What was the original price? So if the original price, everybody, I'm solving for A. So it's going to be A is equal to, it's y divided by 1 minus the rate raised to the x power. So the 6.5% is our rate. Our time is 4 years. Our y is the 18,600. So 18,600 divided by 1 minus, okay, so remember we're going to drop the percent sign and move to left, so 0.065 raised to 4 years. So we're going to put that in the calculator.
Ms. Dutcher, please call 24503. Jane Dutcher, please call 24503.
Okay, and so the original price was $24,000. $336.67. And I'm just going to double check that one. So everybody always double check. Okay, just make sure we're getting these correct. And so everybody, this would be our price for A. The original price. Okay, original prices we're going to be solving for A. Okay, so on the next one, so we have that Alex bought a 5-year-old Honda. Okay, so 5-year-old used Mustang convertible for $19,700. When it was new, it cost $26,500. Find the depreciation rate. So we are solving for R. So it's going to be R is equal to, okay, remember it's 1 minus the used price divided by the starting or the new price, and then 1 over x. So I'm going to do 1 minus, okay, used, so this is the y is the 19,700. Read the problems carefully, everybody. When it was new, it cost 26,500, and then 1 over 5. Okay, so it's going to be 1 minus. Okay, so we're going to have, so I get a rate of 0.0057558. I'm going to multiply that by 100. So I get 5.758. And I'm going to take and round it. Remember, 5 and up, round it up. So it's going to be 5.75%. So 5 7/75%. Okay, so this one, it says Adriana's new car costs $24,000 and depreciates at 2.58% to 18,450. How long did it take? Okay, so it says round to the nearest tenth. So how long means that everybody, we are solving for x. So we are going to be using that formula. So remember I said this is where you need to make your note card because you want to make sure that you got that formula in there. So we're going to have our formula. So it's natural log y divided by a over natural log 1 minus r. Okay, so it's going to be natural log. Okay, new car, everybody, so that's going to be the 24,000 as a. My rate is going to be 0.028 because I dropped the percent sign and moved to the left, add the decimal and the 0, and then y is the 18,450. Read the problems carefully, everybody, so I can identify those variables. Okay, so we put this in. Natural log 1 minus 0.0285. Okay, so I'm going to use, use n over d or math frac, everybody. Use natural log, and then it's going to be 18,400 divided by 24,000. And then we're going to have natural log 1 minus 0.0285. And I got 9.18. So everybody remember 5 and up, rounded up. Tenths place is the first decimal place. So it's going to be 9.2 years. Okay, a car travels 75 miles for how many hours? Okay, so everybody, we're substituting in those hours. So remember it's distance is equal to rate times time. How far? Everybody means we're solving for the distance. Okay, so I'm going to do 75, 73, 73 times 1, so 73 miles. Distance is equal to 73 times 2. Distance is equal to 73 times 3. And then, so all we're doing is just substituting at our different time. Distance is equal to 73 times 4. $292 miles. Okay, so on the next one, everybody, so you're planning a trip to Boulder. So 877 miles to Boulder, Colorado to visit a college. Your car averages 35 miles per hour. How many gallons will the trip take you? So everybody with this one, so we're going to be doing, so remember it's the distance, it's the rate, so miles per gallon, and then this is going to be number of gallons. Okay, so it says how many gallons, so we're solving for G. So we're going to do where it's going to be divided by distance, divided by the rate, which is miles per gallon. Okay, so gallons is going to be equal to the distance divided by the miles per gallon. We're traveling 877 miles to Boulder, Colorado. Our miles per gallon is 35. So we're just going to divide it. So I get 25.057. 5 and up, rounded up. So how many gallons? It's going to take 25.06 gallons. Okay, next one. So it says Jorge uses his car for business and must keep an accurate driving record. So the company will reimburse him for his car expenses. When he started his trip, the odometer read, okay, so everybody, this is what it's when he started, okay, 36,589. When he returned home, the odometer read, so return, 38,079. Jorge's car gets about 42 miles per gallon. If the tank was full at the beginning of the trip and costs $76.67 to fill the tank at the end of the trip, what price did he pay per gallon? So basically we're solving for the price per gallon. Okay, so we're going to subtract. So odometer reading, remember, is on your car. It keeps track of the number of miles that the car has driven. Always double check your answers on this, everybody. So we got 1,490. Okay, the number of gallons. So we take this. So this is the miles driven. So it's the miles driven divided by 42. Okay, so we get 35.476. So I'm going to round that up to 8. Okay, and it says what price did he pay? So it's going to be the cost divided by the number of gallons. Okay, and I got, so we paid an average of $2.16 per gallon. Okay, so total stopping distance. It says round to the nearest foot. So everybody, that means round to the nearest whole number for the speed. Okay, so speed is 50 miles an hour. Remember, that's going to be speed. It's miles per hour. Speed squared divided by 20. So it's going to be 50 plus 50 squared divided by 20. So we get 175 feet. Okay, so this one, everybody, so we're going to be using our formulas for this. So we need to know, okay, so a car traveling on asphalt makes a sudden stop. The drag factor is 0.95. in the brakes operate at 98% efficiency if it leaves 3 distinct skid marks that are 71 feet long. Okay, what's the speed of the car entering the skid? Okay, so they already gave us the average, so we don't need to calculate the average for the skid marks, just so you know. Okay, so it's going to be speed is equal to, I'm sorry, I'll use my lowercase speed, and remember, so it's 30 times the distance, skid mark distance, times the drag factor, times the braking efficiency. Okay, so the distance is 71 feet. The drag factor is the 9.95. Braking efficiency, everybody. Remember, we're going to drop the percent sign and go to left. Okay, so braking efficiency is 0.98. So I'm going to go ahead and substitute those in. Remember, it's the square root key, so it's going to be 30. So do parentheses. So 30 times 71 times 0.95 times 0.98. Okay, so we're going to do square root. So everybody on the calculator, remember it's second and the x squared. Okay, and that's for both calculators, yellow ones as well. So I do parentheses. I just put it all in. Okay. And we want whole number. So I get 44.5. Says whole numbers, 5 and up rounded up. So it's going to be 45 miles per hour. Okay, the next one. So Tanner was traveling and he made an emergency stop. And we need to solve for the distance on this. Okay, so it says Tanner was traveling at 52 miles per hour when he made an emergency stop. His wheels lock and leave 4 distinct marks in equal length. The drag factor is 1.5. So 1 in 500ths. His brakes are at 80% efficiency. How long are the skid marks to the nearest foot? Okay, so that means, everybody, that we're solving for D. So we're going to use the formula D is equal to, okay, it's going to be the speed squared divided by, you do need to do parentheses for this, 30 times the drag factor times the braking efficiency as a decimal. Okay, so we're going to have the speed. So 52 squared. Everybody, you do need to do math frac or N over D for this, everybody. Parentheses 30 times 1.05, 80%. Okay, everybody remember 80%, drop the percent sign and go to left, add the decimal. So times 0.8. Okay, so 52, remember to square that. So do math frac first on this, everybody, and then go 52 squared. Scroll down. Okay, and then you need to do parentheses 30 times 1.05 times 0.8. Okay, and it says how long are the skid marks to the nearest foot? Everybody, that means to the whole number. So I get distance is equal to 107.3. Okay, I'm going to 5 and up, I'd round it up, so it's going to stay the same, everybody. So it's going to be 107 feet. Okay, So that is the distance for the skid marks. Good luck, everybody. You got this. Make sure to read the questions carefully and use your note card.